Hi guys. Today we're doing skill 3. I really kind of like this skill. It's got some like of your own interpretation, and it has some good application for stuff that you've seen and stuff that you're going to see. I don't know. I really enjoyed this lesson, so I hope that you guys do as we go through it as well. Let's go ahead and fill in some of those blanks to start with. If you see something that is called a linear graph, I think it's pretty obvious in the word linear that you see a line. So if something is considered linear, it's a line. Now, lines can go up in direction, they can go down in direction, they can be horizontal, they can be vertical. So it's not always simple as a line, but there are some options. A line, so something that's linear, has a constant rate of change or constant slope. That means the slope is the same. So no matter what point you start at and what point you end at, the slope or the rate of change is always the same. And that's what makes it into a line. If something is nonlinear, it's not a line. Okay, so it's going to have some sort of curve to it. It's going to have something different that makes it not a line. So underneath there, we have two options of things that are nonlinear. We have an exponential, so you can see two graphs. On the left-hand side, you would call that exponential growth. You can see that as you go from left to right, it's going up. On the right-hand side, you would see that that is called exponential decay, going down. For now, you just need to know that that's exponential. It has one direction. It's either going up or going down, depending as you look at it from left to right. Underneath there is quadratic. Now this is something, my guess is you've delved into a little bit in your Algebra 1 classes. Quadratic, I am guessing you're familiar with the word parabola. So what you're looking at are two parabolas. You have a parabola that's opening up and a parabola that's opening down. The ones that open down have a point that's called a minimum, and the ones that are opening up have what's called a maximum. That's very obvious, right? Minimum, lowest point on the graph, maximum, highest point on the graph. What you will come to find out in classes like Algebra 2 is that there are things more than just quadratic. So you can have something that's cubic or quartic or quintic, right? You can keep going up 2, 3, 4, 5. And then those will have maybe two minimums or two maximums. So you're able to have more of those. Again, that's Algebra 2, actually Algebra 2 like a second semester. So you've got some time, no, maybe first semester, but you've got some time before that actually becomes the thing you need to know. For now, just know that quadratic has that U-shaped curve that we've seen before called the parabola. Here are the words, I already used them. So increasing as you look left to right, a line is rising. Decreasing as you look left to right, the graph is falling. So that's an exponential decay or falling. And then constant, so if your graph is not increasing or decreasing, if it's just constant, then you call that a straight or horizontal line. Okay, so rising, falling, increasing, decreasing, and then constant or horizontal. Those are all basically the different directions that your graphs can ultimately go. I think we're ready to get into some of the examples. I'm sorry, so when I scanned this in, that graph did not show up. So you're going to have to look at your graph, and then you'll have a better idea of what we're looking at. It says, which statement best describes the graph of this function? So what you're looking at is that nice U-shaped graph, but what you need to notice is that it is opening down. Okay, so let's go through our multiple choice. Is it linear? You don't even have to keep reading. Is that graph linear? No, it is not a line. A does not work. Is it a nonlinear? So that's a possibility because it's not a line that decreases for all the x values. So as you are looking at that graph, going across from left to right, same direction that you read, as you go from left to right, is your graph always going down? Well, I hope you recognize that over on this side, right, this half of the parabola, if you're looking at your values, you're going up, and when you look at the values here, you're going down, right? As you go across your x's, the y's are going up. As you go across your x's, your y's are going down. So I hope you notice that no, it is not always decreasing. Let's go to letter C. It is a linear function. Done. Don't have to look at the rest of that. It's not linear. Okay? Go to your next one. It is a nonlinear function that increases for negative x values and decreases for positive x values. Does that work? Do you have an increasing and a decreasing? The answer is yes, you do. So letter D works for that. Number 2, it says mark the correct spaces in the table to describe each graph. So for this first one, you can see that there is a line going there. So linear is obvious. If it's linear, then it's not nonlinear, so you pick between those. Is it increasing, decreasing, or both? So again, from left to right, as you look at that line, is it increasing, decreasing, or both, and decreasing? Second graph, it's going up like that. It's an exponential graph, as you can see that. So is it a linear or nonlinear? That's nonlinear. Is it increasing or decreasing? Again, as you go from left to right, what's happening? And it is increasing the whole time. Okay, and then you've got this last graph, and you have to decide the same thing. So decide, is it linear or not linear? So as you follow it along the graph, right, is that a line? No, it's parabola, so nonlinear. Is it increasing or decreasing, or both? Again, it's going up, and then it's going down. So increasing and decreasing, it's doing both. Okay. Well, let's keep going and go to example number 3. It says the graph below represents a function. Okay. Function means it's going to cross the vertical line test, so no matter where I draw a vertical line, it's only going to cross once, so that's good. It says over which intervals is the graph increasing? Select all that apply. Again, on your copy, I think these grids showed up better, so you have a better grasp of where those lines are. Where is it increasing? So start at the beginning. Is it increasing? No, that's constant, that's straight. When you get here and you start going up, is it increasing? Yes. So the first interval that it's increasing, if you look at your x's, are from 2 to 3. Okay, so you've got increasing. Then, again, it's going straight. That's constant. It's not increasing, it's not decreasing. Decreasing, going down. When you get to this point, you start going back up. So that part would be also increasing from 7 to 9. And then at 9, it starts going down, and it's decreasing. So it's those two parts right there. That part C that you could reference and that part H are both increasing values. Okay. All right, go ahead and grab your whiteboards, and we're going to do an example together. Okay? Here is your problem. You've got a graph that looks like that. Left-hand side, so your y-axis says that it's representing velocity. Down here, your x-axis says time in s, so time in seconds. And then you've got those 3 questions. Go ahead and answer those. So please go ahead and pause the video, give the students a chance to answer those questions. Okay, hopefully that was enough time for you to be able to answer those questions. Number 1, what is the independent variable? Independent is your x-axis, and so independent would be your time. Dependent would be velocity. And then it says, give the x values for which the graph is increasing. It is increasing from 3 to 5. So you would say 3 is less than x is less than 5. So you would be writing it like an and inequality. If you remember that from last quarter, we talked about ands and ors. You would be writing like an and because it's anywhere between 3 and 5. Okay, go ahead and go back to your notes. Here are the words that we were just using. We were talking about independent and dependent variables. So here's your chance to actually see that being used. Which is the independent variable and which is the dependent variable? So independent variable is going to be the variable that you get to pick. It's your input. It is the one that does not isn't affected by the other variable. It stands alone. So independent variables are your x values. And just as a reference, time, if your story problem ever has time, generally speaking, that's your independent. Dependent are y values. determined by the x value. So what you plug in for x puts out y, right? So if you think about like a job, how many hours you work determines how much money you make. So hours you work, independent, money you make, dependent. That's how it works, right? The one affects the other. Is it increasing, decreasing, or both? Is there ever a constant rate? So those are the things you're looking for when you're going to sketch a graph. All right, so here we go. It says, draw a graph that could represent the description below. A mountain climber descends at a steady rate. So right there, steady rate means that the rate is going to be consistent, but descending means that it's going down. So it's consistently going down from a mountain peak. After an hour, she stops to rest. Then she continues her descent. She continues to go down. Independent, time. Dependent is her height. How long she's been climbing or descending determines where, how tall, or how far she is still up on the mountain. So she starts here at a height because she's starting at the top of a mountain and coming down. Descends at a steady rate. She goes down. Then for an hour, she stops to rest. She's not going down at all. Time is going on, but her height is not changing. Then she continues her descent. So those are things that you have to think about, right? Is it consistent? Is it changing? Is it inconsistent? Is it curved? Is it straight? These are things that you have to interpret from the story problem. It's not necessarily an easy thing to do. It's really going to make you think a lot about what you're doing. Okay, let's go to number 2. This one already has the graph drawn. You have to answer some of the questions. I do think that you'll find that when the graph's already drawn, it's a little bit easier than the other way around. But let's go ahead and try it. Joyce walked from her home to a bookshop and stopped to buy some stationery. She then walked to a supermarket to stop to buy her groceries. Finally, she walked back home. So, walking to the bookshop, shopping there, walking to the supermarket, shopping there, and then walking home. Okay? The questions. Describe what's happening when the graph is horizontal. Horizontal means she's not changing her distance, which means she's shopping. What is the farthest distance she traveled from home? So look to the top of the y-axis. You're looking at 150 meters. How long was she gone from home? Well, look for time. Time is going across your x-axis. Time would be 80, and put a label on it, 80 minutes. And then the last question, describe what is happening when the graph is decreasing. When it's decreasing, she is heading back home. All right, let's go ahead and go and grab our whiteboards again. Let's see if I can sneak in one quick question for you to try, which is your turn. Go ahead and pause the video, see how the students do, and we'll be right back. Here's the answer to the you try problem. So over here you have time in years. Now my graph looks different than yours because I'm already in my mid-30s, so I'm already here on my graph. Your graph should look a little bit different. Your graph should also look different. I'm almost 6 foot tall. So again, that's where my graph is. Yours is going to look a little bit different. Okay? So I said that by the age 5, you're probably 3.5 feet tall. By age 10, you're a little bit over 4 feet tall. And then by the time I was 15, so high school age, I kind of had reached my maximum height. Boys' graphs probably look a little bit different. They get taller later on in life than girls, so their graph might look different. And some of you might already have reached your peak height, and it is consistent. So you have to think about those things when you're making your graph, right? What you should learn is this. There's a huge increase. This should be a very steep graph, then it should be less steep, and then this constant because you don't change height. So those are some of the things you should think about as you're making that graph for your height. Okay. Independent time, so on your x-axis time in years, and dependent y, height in feet. That's all. That's the graph work that we have to do today. So go ahead and you should be able to start your homework.